Welcome. In this short demo, I'm showcasing the Civil AI Local Assistant, a fully offline AI-powered search tool built for engineers working with archives of technical documents. The objective was to deploy a 100% local AI-powered semantic search system for navigating an archive of civil engineering studies and technical PDFs. The stack uses open models and vector search to support English and multilingual input without cloud dependencies. Let's see the prerequisites. So in order to run the tool, we need to have installed in our system Qdrant, which is a high-performance vector database for embedding storage. We also need Docker, a software platform that automates packaging, deployment, and management of applications into standardized containers. We need to have LM Studio with LLaMA 3 by Meta language, which provides local inference for question and answering. We need to be able to run Streamlit, a lightweight UI interface for quick app deployment and testing. And we also need AIWhispr, which is an open source code tool designed to enable AI-powered semantic search across various document types. We need to make sure that all these are running in our system, and then I'm gonna show you step by step the process. I'm using a simple CMD Windows. The first command, which will be to run the Qdrant via Docker. Then I'm gonna run a Python command which will upload the civil studies which I have stored in a folder. Several civil engineering studies of various types and contents. Some of them are in English, some of them are in Greek in this case. And I'm gonna run this command in order to start parsing the documents. This is gonna take some minutes while it extracts and splits the contents into smart, manageable chunks. It's extracting raw text from each document. For example, if the file has multiple pages or sections, it will split the content into chunks of approximately 200 to 500 words each. I'm gonna pause the video for a while you can see it's running and it's creating chunks for each one of the documents. So after a few minutes, all of my documents have been splitted into chunks, and now I'm gonna move on to embed those chunks, or in other words, to convert each chunk into a vector. I'm gonna run this Python command which I've created earlier. And what this will do is it will produce a vector for each chunk. The vector will capture the meaning of the text, not just the keywords. This is done using a multilingual sentence transformer model that understands both English and multilingual text. The vector will be saved as a JSON file, which will represent a mathematical fingerprint of what each paragraph means, not just the words that it contains. Now we see that it's being run on the screen. It's going to take some time as well, so I'm pausing the video. So after a couple of minutes, all of my chunks have been converted into vectors for each separate document. And these vectors have been saved as JSON files. I can also see here the number of the extracted characters as well as the number of chunks for each document. Now next is my final step in order to run the app. Using Streamlit. It's gonna take me to my browser. Just a few moments for it to open. I don't want to pause it in order for you to see it live. What this will do is when I will type a query, yes, okay, here we see the interface, which is very simple, but does the job. I'm gonna copy a question, describe pneumatic fenders according to text, which is a technical question, and we want the answer to be produced by LM Studio and LLaMA 3 language, which is running there, based on contents that have been chunked from our civil archive. So a few moments for the question to be responded. This tool will understand the intent of the query and will show the best matching document excerpts from the archive. This question itself is also being converted into a vector in order to be correlated with the already uploaded vectors from the archive. So then here is a response. Pneumatic fenders are described as tough and resilient, ideal for permanent and semi-permanent port applications and offshore ship-to-ship transfers. I'm not gonna read the whole text, but this is taking content from one of my documents, and that's it. I hope you like it, and I hope it is approved as a lesson from the tutorial of Civils AI. Thank you for watching.